Plate tectonics.
The first thing we need to bring up are convection currents.
A convection current is basically the driving force under the plates of the Earth.
A convection current happens when the hotter, less dense material rises up and when the cool stuff drops down,
Creating a sort of rotation.
the material we mentioned, it's made up of magma.
Now we need to bring up those, what are they called?
Boundaries.
Yeah, those.
First, there's transform boundaries. They happen when two plates slide against each other.
They can either slide with each other
Or against each other.
Earthquakes and cracks in the crust
Or faults.
happen here.
A familiar fault just happens to be the San Andreas Fault. Right there in California. There's also convergent boundaries, which split into three groups.
Oceanic subduction, continental collision,
And don't forget continental-oceanic subduction.
right. Just so I don't forget, let's start with continental oceanic subduction.
This is where plates move toward each other.
When they meet, the denser, colder, older plate, or oceanic plate, subducts under the less dense plate, or continental plate.
So the oceanic plate subducts under the continental plate. As the oceanic plate goes under the continental plate, it continues to get hotter and hotter until it melts into magma.
This is where coastline mountain ranges form, like the Andes and Cascade Mountains.
Hold on, not those Andes. Wrong picture. But volcanoes also form, and this is where you feel earthquakes.
It's not recording, isn't it? Oopsies.
It works.
Next is oceanic subduction. This is where the plates move towards each other. Dude!
Since both plates are around the same density, they do what the continental collisions do, except
Next is oceanic subduction. This is where the plates move towards each other.
since both plates are around the same density, they do what continental collisions do, except instead of going up, they go down.
Which creates islands and deep sea trenches.
You will feel earthquakes, see volcanoes, and be in tsunamis.
Japan, South Sandwich Islands, and the Aleutian Islands were all created this way.
Islands are formed when magma comes up from the cracks and splits between the plates. This makes an underwater volcano. The more it erupts, the more rock gets piled up on top of it, and the taller it gets.
Soon it reaches the surface, and the volcano keeps erupting. Now the lava spreads out, and layer after layer, you have an island. I fucked up that last.
Here are some examples of what can happen. A volcano, a tsunami with our little surfer, and an earthquake. Now we have continental collision.
That's when the convection currents push two continental plates towards each other.
And bang,
The force of the plates makes their edges go up in the air.
making mountains!
Like the Himalayas, this is also where you'll feel earthquakes.
Here are the Himalayas. Let's go inside out. In the center is the inner core.
The inner core is 1,491 miles thick and 6,998 degrees Fahrenheit. It's composed of iron with nickel and sulfur. The layer is solid due to the immersed pressure being exerted on it.
The outer core is comprised of the same materials that the inner core is, except for the fact that it's molten. It's 1,367 miles thick.
With both the upper and lower mantle combined, we get the lower mantle, which is 1,770 miles thick. It's composed of sulfate materials. It's hot enough to have molten rock or magma.
The upper and lower mantle are almost the same thing.
Now, the asthenosphere.
It's basically the top of the upper mantle. It is very smooth and slippery.
Add the lithosphere. It's the layer that the plates move on. It's very smooth and slippery as well.
Continental and oceanic crust is what the plates are made of. It is rigid and composed of granite and basaltic rocks. It is anywhere from 3 to 31 miles thick.